27, the last problem. We've got a little bit of a word problem here. At the beginning of 2015, right? So right there, that tells me that's going to be my time 0. Oops. That's when we started, 2015. A tank contains 1,200 gallons of water. All right, so that is basically my initial point right there. At time 0, I've got 1,200 gallons. That's the point right there. The increasing function, it's always increasing, models the total amount of water inside the tank. All right. So P is the amount in the tank. Alright. And T stands for, let's see. You know, it really should, oh, T is measured in years, thank goodness. Okay. It's very important. And T is in years. This is my T, this is my P. Alright. We'll satisfy the differential equation. That just means that that's a derivative. So if that's the derivative, what does that represent? The derivative is the rate of change of the function. So if the function is P, the amount in the tank, then the derivative is the rate of change of the amount in the tank. So dP dt, good Lord, is the change in P, which is the change in gallons, over time. And time is in years, so gallons per year. P is measured in gallons, T is measured in years from the start of 2015. Use the line tangent to the graph, meaning we need the derivative, to approximate the amount of water at the end of 4 months. Okay. 4 months is our time, but we're not measured in months, we're measured in years. So 4 months is what fraction of a year, right? 4 months out of 12 is a third. So our time is 1/3. Right, so to find the line tangent to the curve, I need 2 things. I need a point and I need slope. Alright, so let me give myself some room here. Alright, T equals a third. Alright, but we've also got T equals 0. So it says use the line tangent to the graph at T equals 0 to approximate the time at 1/3. So we're going to use this point to set up our tangent line, and then we're going to plug in 1/3 at the very end. Okay, so I've got my point. It's 0, 1,200. My slope is going to be what I get when I plug in at that time. So what is the slope at 0? 1/30 times P at time 0. P is 1,200 minus 200. All right. So I just plugged in 1,200 for P. We're actually not plugging in 0 for T. We're plugging in 1,200. All right. And you can use your calculator, or you can simplify that, but it does come out to be 100/3. So that's going to be my slope. All right, let's do it. We've got y, well in this case, not y. Let me use the right letters. P minus P1, which is 1,200, equals the slope times x, which is t, minus t1. Very nice. And now we want to know, okay, that's the equation of the tangent line. So what is the approximate value of p when t equals 1/3? So I'm going to solve for p since that's what I've got to find. All right, and let me go ahead and plug in t is 1/3. All right, and you can simplify that by hand or using your calculator. Let's see, I didn't do this ahead of time, so let me calculate it real quick. I'm not going to use the app, I'm just going to use my calculator. 100/3 times 1/3 plus 1200. Alright, so you can write your answer as a decimal or a fraction. As a decimal, I'm getting 1211.111. And what are we finding? P? P is in gallons.